Very good morning, students. So in this video I wanted to explain about axiomatic definition of probability. So till the previous video we have seen assigning the probabilities methods. One is classical method, another one is a statistical method. The another name of classical method is priori or mathematical, and another name of statistical method is posteriori or empirical. And in practice generally we use classical method of probability, which is probability of A equals to favorable upon exhaustive. Now today the very most important definition, which is axiomatic definition of probability. So in the examination viewpoint many times this question had been asked. It has been asked many times for 2 marks. And let us see the definition. Axiomatic definition. Let A and B be the events of a sample space, and probability of A and probability of B are the probabilities assigned to the events. Then when do we say the probability of A? If the axioms are satisfied, look at their axioms. Probability of A means any event which assigned the probability, that probability must be always a positive. That means non-negativity, we can say. So it should come always the probability value positive value. Negative does not exist in any probability case. Clear, guys? That is axiom number 1. If the probability of A must be greater than or equal to 0, that means there is no negative, non-negativity, we can say it as a positive, right? If the probability of any event satisfies this non-negativity, and then second axiom, probability of that whole sample space must be equals to 1. As you all know that the total probability is always equals to 1. The whole sample space probability of the entire sample space sure event is always equals to 1. That is condition number 2. And the third condition is for any two disjoint events A and B, there must be a formula always which generalized in case of mutually exclusive case also. Probability of A plus B equals to probability of A plus probability of B. Here A and B are disjoint. We can say it as mutually exclusive, one which prevents the other in a single trial. Clear? So if we satisfy all these three axioms, then definitely we can say that probability is an axiomatic definition of probability. So axiomatic means if we satisfy all these three axioms in any case, in any event of the sample space, assigning the probabilities, if we satisfy all these three axioms, then we can say that definition is a axiomatic definition of probability. Clear, guys? So axiom number 1, there must be always a positive. Any probability of any event, there must be a positive, non-negative, and probability of the whole sample space must always be equals to 1, nothing but a sure event. And third axiom is for any two disjoint events in case of mutually exclusive case, which is generalized, the formula would be P of A plus B equals to P of A plus P of B. Here A and B are disjoint events. We can say it as mutually exclusive. Clear? So this is the axiomatic definition of probability. So yesterday we have seen the classical method, which has 50-50 chance of any random experiment. If you take the outcomes, individual outcome has an equal chance, right, of probability. That is a classical method. Second one is a statistical method. If the experiment is repeated n number of times up to infinity, definitely in practice it is not at all possible converting the probability. Clear? If n is large in the sense if it goes up to infinity, the limiting case, if it n goes to infinity, definitely the probability becomes large. We cannot calculate that, isn't it? That's why in terms of distributions it has been converted. So in this concept we have totally concentrated on the classical definition, which is a priori definition of statistics. In that priori definition, definitely the n must be a mutually exclusive exhaustive and equally likely events it should be, remember, right? And what are the limitations of the classical method? We have seen it should be a mutually exclusive, exhaustive and equally likely event it should be. And another thing is that n must be a finite. In statistical method n is infinite, but wherein classical method n is a finite. Now here the axiomatic definition, the third one, right? So look at this axiomatic definition followed by 3 axioms. Probability of any event must be a positive, greater than or equal to 0, and probability of the sure event will always be equals to 1. And for any two disjoint events, in case of mutually exclusive, P of A plus B equals to P of A plus P of B. Clear, guys? So let us see the short theorems, I can say that short results, which I am going to show it now in the continuity of this video. Clear? So let us have those short theorems. So look at the results. Probability of any null event. So probability of null event, empty event, is always equals to 0. So as per the definition, probability of any event equals to number of favorable by number of exhaustive, right? So probability of null event equals to number of null events divided by total exhaustive cases, n of null divided by n of sample space, yes, I mean a number of exhaustive cases. So that equals to 0 by n equals to 0. It's a very short theorem, guys. Okay, short results they are. So just for 1 mark, 2 mark they may be asked. So probability of the whole sample space sure event is always equals to 1. So probability of null event is always equals to 0 as per the definition. So we proved that it is 0. And probability of entire sample space or nothing but a sure event is nothing but equals to 1. So by definition, if you substitute, you will be getting 1. Look at the proof there. Probability of the sample space, probability of S equals to n of S divided by exhaustive cases, that is n by n equals to 1. Now as you all know that probability value will never be a negative, right? At the same time, the total probability value lies within 1. So 0 to 1. Probability of any event you consider, the value will always be coming between 0 and 1. Its value lies between 0 and 1. So as you know the definition, probability of any event equals to favorable by exhaustive. Favorable is denoted by m and exhaustive is denoted by n. So here n means it's an exhaustive whole, the total, right? Total number of possible outcomes, number of exhaustive outcomes. But wherein m definitely lies between 0 and n or not. I mean n is a total, right? Exhaustive total, and 0 is the least minimum. So definitely the least and highest values of m would be 0 and n, right? So look at the condition there, 0 less than or equal to m less than or equal to n. That means m lies between 0 and n. If you divide that by the sample exhaustive outcome n, then look at there, 0 by n less than or equal to m by n less than or equal to n by n. Definitely m by n is nothing but, as per the definition, probability of the event, and 0 by n is 0 and n by n is 1. So hence proved the probability of event A is always lies between 0 and 1. The probability of any event lies between 0 and 1. Clear, guys? So every time you need to remember 3 things. One is the total probability will always be equals to 1, right? And probability value will never be a negative. Third one, the probability value will never ever cross more than 1 and less than 0. No negative and not more than 1. Clear? So the least value and the highest would be 0 and 1. Remember. So these 3, if you remember, the whole probability concept will be understanding. And another thing is the formula, probability, classical method, the probability of any event. If you take it, favorable by exhaustive. So this is the formula you need to learn. So there is one more short result, which is probability of A plus probability of A complement is always equals to 1. You know that, right? So let us have that also. Result number 4. Look at that fourth result. Probability of A plus probability of A dash, nothing but complement of A, is always equals to 1. So here A union A dash will always be equals to the whole sample space, right? Union, the total. A union A dash, I mean probability of A and probability of A dash together, the total will always be a sample space. Yes. Apply probability to that. Probability of A union A dash equals to probability of yes. And as you all know that disjoint P of A plus P of A dash, right? In case of union, we will get 1. But in case of intersection, A and A complement will always be 0. Remember. So A intersection A dash will always be null, 0. But A union A dash will always be equals to 1, the total sample space. I mean probability of the total sample space is always equals to 1. Clear guys? So these are the 4 results. Now let us have few basic problems from the probability theory, and later on we are going to do few more analytical kind of problems, and then where we can apply the addition theorem, multiplication theorem, conditional probability, all those. But initially you must learn only one formula, that is favorable upon exhaustive. Always remember this one. Clear? So probability of any event will always be favorable by exhaustive, denoted by m by n. M is denoted as favorable, n is denoted as exhaustive. Clear? So let us have those basic 1 mark 2 mark problems now. I hope the theoretical concepts right from the definition of probability to all these results, I mean till axiomatic definition, I think you understand. I hope everybody is followed all those theoretical aspects. If you understand the theoretical aspects, definitely concept will become easily understood. Clear guys? So let us have the basic problems, initial random experiment problems, wherein like throwing a die, playing cards, and then tossing a coin. So basic problems, isn't it? So let us have such kind of problems in this video. Okay, just look at these 2 questions guys. Problems on mathematical method or mathematical definition of probability. Example number 1. When a coin is tossed, what is the probability of getting head? That is question number 1. Next, see, directly we can say when a coin is tossed, possible exhaustive cases are 2 and getting head will be 1. Then what is the probability of getting head? 1 divided by 2, favorable by exhaustive. Getting favor of head will be 1 when a coin is tossed, and exhaustive total possible outcomes were head and tail 2. So head divided by head and tail 2. Clear? So 1 by 2. Now this one only in a easiest way, I mean in an elaborative manner, for 1 mark it has to be calculated. So directly it cannot be written. Probability of getting head is 1 by 2. We need to write always any kind of random experiment, learn writing sample space first. Okay, so let us consider what exactly the event in this problem. Let us have a look. What is the event in this problem? Look at this. What is the event here? Probability of getting head. Getting head is an event. So let us consider that. Let A be an event of getting head. And when a coin is tossed, what is the sample space? As I said that every problem you need to learn writing sample space. S equals to head comma tail. Therefore, exhaustive number of cases are 2. So n equals to 2. And then getting head from the sample space, yes. How many are there? 1 head. Only 1. That equals to 1. So favorable cases are 1. M equals to 1. Therefore, the probability of event A equals to favorable by exhaustive, that is M by N equals to half. Clear? So always you need to learn writing sample space, favorable cases, exhaustive cases, and then directly substitute in the formula. Formula in the sense the probability of event A. So here the event A what we have considered, that is event of getting head. So this is the problem. This problem when single coin is tossed. Next, look at the second question. When two different coins are tossed, what is the probability of getting, question number 1, 2 heads and getting 1 head. So when two different coins are tossed, now what exactly the event here now? Here also probability of getting heads only, but number is changed, 2 heads and 1 heads, but the event will be always getting head even in this question. So let us write that one. Look at this question. When two different coins are tossed, what is the probability of getting 2 heads and 1 head? So here two different events are there. What is that? One is getting 2 heads and the other one is getting 1 head. So let us consider two events. Let A be an event of getting 2 heads and B be an event of getting 1 head. So now what is the sample space when two coins are tossed? Look at that sample space. Head comma head, head tail, tail head and tail tail. So this is the sample space when two coins are tossed. Now question number 1, what it is getting? 2 heads. Out of these 4, getting 2 heads. How many cases were there? How many possible favorable cases were there? Only one, that is head comma head, right? Head head, that is only one favorable case. So let us consider that A equals to head head, that is favorable case is 1. Therefore probability of A equals to favorable by exhaustive, favorable is 1 and exhaustive will always be 4. Total possible outcomes, clear, that will be the exhaustive denoted by N. M will be the favorable, getting 2 heads out of 4, only one case. Next question number 2, getting only 1 head. Getting only 1 head, how many are there out of those 4? Head, tail and tail head. Only these 2 cases we are getting only 1 head. In tail comma tail no heads and in head comma head there are 2 heads. But here the question is asked only 1 head. Therefore the favorable case will become 2 head, tail and tail head. Therefore probability of event B equals to favorable by exhaustive, that is favorable 2, exhaustive will be 4. Therefore that is equals to 1 by 2. So 2 by 4, that is equals to 1 by 2. Clear guys? So let us have another few examples, few more examples. So I think you will get a clear picture about the probability, how the sample space have to be written, and then how the events are to be taken, and then how the probability value should be calculated. Clear? So let us have few more problems based on the mathematical model. Basic problems there, right? Look at this problem. A die is thrown once. What is the probability of getting an odd number? Question number 2, an even number, and 3, a multiple of 3. So totally when a die is thrown, what are the possible outcomes? Sample space S equals to 1, 2, 3, 4, 5, 6. So total exhaustive number of cases are 6 denoted by N. Now we need to find out the favorable from the experiment, random experiment, that is throwing a die. Possible outcomes 1 to 6. Now question number 1, an odd number. In a die odd numbers were 1, 3, 5. Therefore favorable number of cases are 3. Then probability of that getting odd number will become favorable, 3 by exhaustive 6. So 3 by 6, that is 1 by 2. Next question number 2, an even number. Even numbers are 2, 4, 6 from the die. So favorable cases are 3. Probability of B equals to, probability of getting even number equals to favorable by exhaustive, that is 3 favorable cases, 2, 4, 6 and 6 exhaustive cases from 1 to 6. Therefore that is also 3 by 6, 1 by 2. Next question number 3, multiple of 3. Multiple of 3 we have only 2, which is 3, 6. Favorable cases are only 2 here now. Therefore the probability of getting a multiple of 3 is favorable by exhaustive, that is M by N equals to 2 by 6, that is 1 by 3. Remember guys, probability answer can be in fraction or in decimal also, no issues. So you can convert that in terms of fractions or else in decimals. So both you will be carrying full marks, remember. But always remember step number 1, writing the event according to the probability which is asked, right? Second thing is writing the sample space or else exhaustive cases. Third thing is like bifurcating the favorable cases. So these are the 3 steps. Whenever any probability problem you calculate, 3 steps you remember. First thing, writing an event. Next thing, writing the output, I mean total number of outcomes, sample space along with the exhaustive cases. Step 3 is favorable cases and calculating the probabilities. Clear? So this is a problem. So in the next video, I am going to explain few more problems. Now these are all the basic initial problems. Still there are further more maximum number of problems we have in probability concept, which are now the level 1 you are calculating. Remember guys. So level 1 is the easiest kind of problems, just like 1 mark, 2 mark problems. Level 2 will be the 5 mark problems, which are like moderate come difficulty level. Right? So 2 levels we have, level 1 and level 2. Level 3 will be the conditional probability, which you are going to calculate still more further. Clear? So initially we are doing now level 1 problems. So with this, I am going to wind up this session. So hope everybody is following the videos and learning, understanding the concept of probability theory. Hope you guys are understanding and following thoroughly. And remember guys, practice. Thoroughly you practice, definitely concepts are very easy and very simple. You need not worry much the concept of probability, and definitely this will help you even in your mathematics subject also, right? You have around 11 marks or something weightage, as well as in the competitive level 4 questions will come. In JEE level 4 questions, 4 fours are 16 marks you can carry up. You know that JEE 1 mark also matters a lot. Thousands together ranks will get changed. So remember, so don't lose the hope. Being a statisticians, being a statistics students, so probability concept, if you learn in statistics subject, definitely you will come up in mathematics also. Almost the same, 99.99% it is same. Okay, only the thing is we use different kind of notations and mathematicians will use different kind of notations. That's it. Apart from that, everything remains same. We always used to write probability of A is m by n. They always used to write n of s or n of a by n of s, like that. Okay, number of. That way they used to write it. So both are one and the same guys. Favorable by exhaustive only. Clear? So with this, I am going to wind up this session. So let us have few more problems in the next video. Hope everybody is doing great and healthy. Stay home, stay safe. Do not waste your time guys. Have a nice day. Thank you.